Hi, folks. Welcome back to Sourced by Cofactr, the show that cuts through the noise and gets to the good parts. I'm Ed Dodd. Really great to have everyone joining us once again. Okay, I have to admit, when someone first suggested today's title, it made me laugh. How I Learned to Stop Worrying and Love the BOM Scrub. Classic. It's got that whole Doctor Strangelove vibe, which sort of implies that a bomb scrub is this, world-ending event we just have to live with. Well, maybe for some people it feels that way. And if you're not in the industry, it sounds like a spa treatment, right? Come on in for a facial and a bomb scrub. I really wish it were that relaxing. But I think for you hardware folks, the supply chain people listening, they know exactly what it is. It's a nightmare. It's the one thing that stands between a cool new design and, well, an actual product. I mean, if you want to get dramatic about it, the Bob Scrub is really the difference between launching on time and losing millions, all because you can't buy one 10-cent part. And that's the hook right there. So today we're unpacking why it usually starts as a mess, how you clean it up, and why this scrub is actually two very different jobs pretending to be one. You see, it's not just spell check for a spreadsheet. It's one part detective work and one part fortune telling. So let's just set the table. The bill of materials in a perfect world, this is just the recipe for your product. It's your list of ingredients, every resistor, every capacitor, the main chip, the connectors. If it goes on the circuit board, it has to be on the BOM. It's probably the most critical document in manufacturing. But the whole premise here is that the BOM an engineer gives you is almost never ready for the factory. Why? Why is it always so dirty? It's not on purpose, it's just that the tools engineers use, CAD software like Altium, their job is to make sure the circuit works. The engineer picks a part because it has the right capacitance, the right specs. They're not necessarily checking if a distributor has 50,000 of them, or if the part number includes the little code for, say, tape and reel packaging. So the engineer is focused on function, and the supply chain team is focused on logistics. The BOM scrub is the bridge between those two worlds. It breaks down into two big phases. You've got part matching, and then you have risk assessment. Let's start with phase one, part matching. I mean, it sounds simple. You have a list of parts, you match to a database. Done. Why is this so hard? Oh, if only. The problem is the databases you're matching against are the entire global supply chain, millions and millions of parts. And your list was probably typed by a human who makes mistakes. So the goal of part matching is to take that line from the CAD tool and connect it to what we might call a golden record. A single source of truth, a verifiable purchasable part we can match in multiple databases at distributors or data aggregators like Octopart or Silicon Expert. And the key to doing that is the MPN, the manufacturer part number. This part match really breaks down into two levels of concern. Let's call them definitely bad and maybe bad. Definitely bad means we can't match the MPN in any database at all, not even one. It's often just a typo, but it still creates a dead end. The engineer meant to type TMS for a Texas Instruments chip, and they typed TXS. Now you search for it, you get nothing. Annoying, but easy to spot. It's the other concern, the maybe bad, that can really create problems for you. Maybe bad is an MPN that matches in one or more databases, but not all. So that means it works in some places, but breaks your automation everywhere else. A classic example is a distributor suffix unique to the distributor. So say you want a regulator from TI. The official MPN might be, a string of numbers. But when you look it up on DigiKey's website, they often add ND to the end. That's just their internal code. And the engineer just copies and pastes that whole thing and the included into the BOM. And for a moment, it works. But then a month later, you try to feed that BOM into another distributor's upload tool. Their system looks at that part number with the ND and has no idea what it is, right? It breaks everything. Another altogether separate element of part matching is the manufacturer name. Did your data say Texas Instruments or Texas Instrument Inc. or maybe just TI? There are over 1,000 component manufacturers. This can be such a pain. And then there's the acquisition trap. The semiconductor world is always consolidating. A big fish eats a smaller fish, like when Intel bought Altera. AMD bought Xilinx. How does that break a bomb? An engineer might be using a part library they set up 5 years ago. So in their software, a part is listed as being from Altera. They export the BOM and it says manufacturer Altera, but now it's actually Intel. The supply chain databases, they've mostly been updated, so they list that part under Intel. Your tools try to match and the system just returns an error. It's a ghost. Okay, let me just push back for a second. Why is this such a huge deal? Can't the person buying the parts just figure it out? Oh, right, Altera is Intel now. Why do you need a whole formal process for this? It's this kind of thinking that leads to what we call data rot. Data rot. That sounds unpleasant. It's a structural problem. Here's how it plays out. You send that messy BOM to a distributor, the sales rep there, they want your business, right? They're not going to just reject it. No, they'll fix the errors manually. They know all the little tricks. They strip the suffix, they change the links to Intel, they get you a quote, you buy the parts. Seems like a win, right? But you never fix the source problem. The MPN and manufacturer combo are still wrong. So 6 months from now, when you need to order again, or you try to automate things for a bigger production run, you hit the exact same wall. You are literally depending on the memory of one sales rep to build your product. That does not scale. It's like building your entire manufacturing process on a foundation of sticky notes and manual emails. A formal scrub forces you to correct the data at the source. It creates that clean master file that can move between systems without a human having to hold its hand. Okay, so that's phase one. We fixed the typos, updated the names, stripped the weird suffixes. We have a matched BOM. But we are only halfway done. A matched BOM is not the same as a ready BOM, not at all. This gets us to phase two, risk assessment. We stop looking at the spelling and start looking at the risks. And the first big risk is compliance, the dreaded alphabet soup of regulations. Fun stuff like RoHS, REACH, Prop 65. Most people have probably heard of RoHS, basically the no lead rule. REACH is the restriction of hazardous substances. For the most part, no lead, no mercury, no cadmium. It started in Europe, but now it's basically a global standard. If your product isn't RoHS and REACH compliant, you can't sell it in the EU. End of story. Then, of course, the goalposts are always moving. The big one right now that's keeping people up at night is PFAS, the forever chemicals. And regulators are coming down hard on them. And unlike lead, which is usually just in the solder, PFAS can be anywhere. The plastic casing, the wire insulation, everywhere. So a good BOM scrub means checking every single part against this massive list of banned chemicals. And what happens if you miss one? One little capacitor has a banned chemical in it. Your entire shipment can get held up at customs. You could face huge fines, or even worse, you have to do a full product recall and redesign your board just to replace that one part. It is a complete disaster. So compliance is all about making sure it is legal to sell your product. And it can be industry specific too. If you're building for cars, you need automotive grade parts. For defense, it might be mil-spec. It's about making sure the part is allowed to be used where you want to use it. Okay, so the next layer of risk is time, the lifecycle status. This feels like the existential dread part. It is a little grim. Every electronic component is mortal. It's designed, it gets produced for a while, and then it dies. And as the person scrubbing the BOM, you have to confirm every part on that board is actually available. So let's walk through the stages of component grief. Stage one is active. The part is in full production. Everyone's happy. You can buy as many as you want. And then things get complicated. First, you hit NRND. That means not recommended for new designs. That sounds very polite, but it's a huge warning shot. It's the manufacturer saying, look, we're not killing this thing yet, but please, please stop designing it into new products. If you see an NRND part on a BOM, you should probably find a replacement immediately. And if you don't, you might find yourself at EOL, end of life. The countdown has begun. Now you're really on notice. And this is where the LTB comes in, the last time buy. When a part goes EOL, the manufacturer gives you a window, maybe 6 months, maybe a year, to place all your final orders. You have to guess how many you'll need for the entire remaining life of your product. Depending on loss of circumstances, that might be impossible. If I'm making a medical device that has to be supported for 10 years, I need to buy a decade's worth of these chips right now. That's the terrifying math you have to do. And then you have to pay to store them in a safe environment and hope they don't go bad. And if you missed that last time buy window, now you're in the final frontier. It's obsolete. It's gone. The production lines are retooled for something else. And at that point, you're looking at the gray market. You're calling brokers. You're running a huge risk of getting counterfeit parts. It is not a good place to be. These notices, the ones that tell you a part is on its way out, are called PCNs, Product Change Notices. You might be surprised to learn there are actually industry standards for this. It's not just a casual email. It's becoming very formalized. JSTD 046 and 048 are standards that define exactly how a manufacturer has to notify you that a change is coming. They can't just, change the recipe for their silicon overnight. And for defense applications, there's even a specific one, IEC 6242, obsolescence management. If you are building a fighter jet that needs to fly for 30 years, you can't have a critical chip just disappear. The Department of War requires you to have a very detailed plan for that. Okay, so we've checked if the part is real. We've checked if it's legal. We've checked if it's still alive. Now for the big one, availability. Can we actually buy it? This is the ultimate reality check. You can have a part that is active, totally compliant, perfectly matched, but if the lead time is 52 weeks, you're waiting a year to build anything. A year! Or maybe there's just zero stock anywhere in the world. We all saw that happen during the big chip shortage. Perfectly good, normal parts just gone. So what's the defense against that? Multi-sourcing is the gold standard. This is so important, and it's something a lot of people misunderstand. A lot of engineers think multi-sourced just means, oh, I can buy this part from DigiKey and from Mauser. But that's not what it means. No, that's just two different storefronts selling the exact same thing. If the one factory that makes that part burns down, both of those stores are going to run out. True multi-sourcing is when you have approved part numbers from multiple manufacturers for the same component. So for a common resistor, I could use one from Panasonic or one from Yageo or one from a dozen others. They are form, fit, function equivalents. If Panasonic has a shortage, you just pivot and buy from Yageo. No redesign needed. That is your ultimate safety net. But you can't do that for the complex parts, no. And that's the hard part. You can find a dozen equivalents for a simple capacitor, but if your entire product is built around the very specific microcontroller from, say, ST Micro, right, you are married to that part. There's no just swapping in another one. Okay, at this point, we need to talk a little bit about context. Risk is relative. For example, comparing a prototype build to a full production run, right? If I'm building 5 boards for a demo next week, then who cares about the long-term life cycle? If a part is NRND, so what? You just need 5 of them right now. You should prioritize immediate availability over everything else. But for mass production, that's a terrible idea. The priorities completely flip. You need longevity. You need a stable supply. You need a good price. You absolutely cannot risk a part going obsolete 6 months after you launch. This brings us to what we might call the 10-cent problem. This is the ultimate supply chain nightmare. So imagine you make a fancy industrial controller that sells for $1,000. It's got hundreds of parts on it, and one of them is a totally generic 10-cent capacitor. Now, if you run out of the $50 processor, of course you can't build. Everyone gets that. But if you run out of that 10-cent capacitor, you also can't build. Your $1,000 product is stuck on the assembly line waiting for a part that cost a dime. And your revenue for that product might drop to 0. That's a line down situation, and it costs a fortune. This is why the BOM scrub is so vital. It helps you identify that 10-cent part as a risk long before it shuts your line down. And if you know it's a risk, maybe it's better for you to just spend $5,000 to buy a year's supply and stick them in a warehouse. That's incredibly cheap insurance against availability or lead time problems. It's practically free when you compare it to the cost of not shipping your product, but you only know to do it if you've done the risk assessment. And the alternative, trying to swap a part out at the last minute, isn't free either. It's almost never just plug and play, especially not in regulated industries like medical or aerospace. If you change a part in the power supply or something that affects radio emissions, you might have just invalidated all of your safety certifications, like the UL listing or the little SCC sticker on the back, or the CE mark for Europe. If you swap a part, in some eyes, it's technically a different device. You may have to go all the way back to the testing lab and get it recertified. That can cost tens of thousands of dollars and worse, months of delay. That's the kind of math that can put a company out of business. It just highlights why you have to do all this work up front before you ever start building. We started out joking about the BOM scrub being this annoying chore, but it's actually it's a critical strategic defense. It is the bridge between the design intent, what the engineer wanted to build, and the real world. It's what turns a parts list into a ready BOM. It's validated, it's legal, it's alive, and it's importable. That's what you want. A file you can just feed right into your other systems, your ERP, your PLM, your suppliers, without anything breaking. So this is really a call to action. If your whole process relies on manual fixes, on just hoping your distributor catches your mistakes for you, you're building a house on sand. You have no foundation. So the next time a supply chain crisis hits, and there is always a new crisis, you'll be blind. The only way to navigate it is to make sure the data inside your own system matches the reality of the market before you need to buy. So I guess the big takeaway is stop treating the BOM scrub like a janitor's job. It's not about cleaning up a mess, it's about immunizing your product against the chaos of the real world. Immunization against chaos. I really like that. That's a perfect description. Well, on that note, I think we've given everyone a lot to think about. A reason to maybe look at your spreadsheets with a bit more respect, or a healthy dose of fear. A little of both is probably good. Thanks to everyone for joining me on Sourced by Cofactr. I'm Ed Dodd. I hope we cut through some noise and helped you get to the good parts. We're really excited about our PaaS service model. It's free to use, so check it out today. If you found this episode valuable, please subscribe and follow Cofactr as we continue to revolutionize electronic hardware.